Hi all, welcome back. And in this video, we are going to learn about partially ordered relation. So, what are the partially ordered relation, right? So, we can call a relation R on set A, which is reflexive, okay, and symmetric, antisymmetric, not symmetric, it's antisymmetric, and it is transitive. If a relation on set A is reflexive, antisymmetric, and transitive, then it is known as a POR. That is also known as partially ordered relation. Okay, so partially ordered relation is a relation on A which is reflexive, antisymmetric, and transitive, right? So let's say an example we have here, and in this example we are defining less than equal to, and that's this we are defining on integer set A. So is it partially ordered relation or not? So you consider any set of relation like something like 1 2, okay, or 0 and -1, like this. So if we are defining this way, so like this, if we consider this as a set of integers, right? So let's say, let's define z only. So I think if we define it like something called 1 1, if we define something 1 1 or 2 2 or 0 0, like this inside this z, I mean this is our relation, so this is reflexive. So we can say that yes, it includes a reflexive part. Now second is symmetric, antisymmetric. Now what does antisymmetric means? Antisymmetric means that if AB is present and BA is also present, then A has to be equal to B. But if we are defining this less than equal to sign, then it is definite that either it both will be equal. But if something is less than something, like if we have something called 1 2, then for this we have 2 1. Like if we have 1 2 and we have 2 1, then 1 has to be equal to 2, right? But this condition is of condition of antisymmetric. But if we have already 1 2 present in this set z, and we have this less than equal to, can we have 2 1? No. So for every 1 2 we cannot have the opposite direction, right? So definitely it is antisymmetric. And regarding transitive, so transitive also is agreed on to, because if we have 1 1 and then we have 1 2, then we can have 2 1 2, okay, like this is a case of transitivity. But we can't have 2 1, so this is a transitive relation as well. So we can say that if we are defining a relation less than equal to on z, then this is a POR, partially ordered relation, right? So this relation on z, it is also defined as z and less than equal to, and this is defined as a POR, partially ordered set. So this is the relation, and it is defined on integer set z, right? Let's take another relation on integer set A, and that is, let's say, divide on integer set z. So is it a POR? So let's see. If we have a 1 1, yes, it is a division operator. If we have a 1 2, so all the 2 2 1 2 and so on up to n, whatever, this is reflexivity is agreed, right? I mean, for division operator it will contain these all, okay. If we define 1 2, so 1 divides 2, right? If we say 2 3, so 2 divides 3, it is not there. Or if we say 2 4, so 2 divides 4, yes, it is there. Can we say something like 4 2? If 2 4 is there, 4 2 will not be there, because if 2 will divide 4, 4 will not divide 2. So that is how this anti-symmetric condition is satisfied here, right? But since it is on z, you have to agree that it has to be it can be 0 0 also. So if 0 0 we define, so 0 divides 0, is it allowed? No, it is not allowed. Why? Because this is this will contain all the positive and negative integer along with 0, right? If we subtract 0 from here, then definitely it is agreed. But if we are defining just z, that is a set of integer, then 0 0 will not be there in division operator, because 0 does not divide 0, right? So reflexivity is cancelled from here. But if we say anti-symmetric, again for anti-symmetric also, if this is cancelled, if we say anti-symmetric, anti-symmetric means if 1 0 1 2 is there, and let's say we have 2 1, then 1 has to be equal to 2, like this is anti-symmetric condition. But if we are defining 1 2, and then we are defining something, let's say we have 1 1, and 1 divides 1, and then we have but I think 0 0 will fail our condition for this. So this won't be satisfied. But yeah, 1 2 is there, and 2 4 is there, then definitely 1 4 will be there. So transitivity is defined. Okay, so this division operator on Z is transitive, but it is not POR. Why? Because 0 0 condition is not satisfied, right? Let's see another condition. So you have to check the edge cases also, because if we define this division operator on positive set of integer, then definitely it is reflexive, because 0 0 is not included here, right? And it is antisymmetric as well. Okay, we have just seen. And what else, it is also transitive, because already we have seen that it is transitive. So on positive set of integer, it is a partially ordered relation. Okay, so this way we can determine whether a set is a relation defined on a set is partially ordered or not. Let's see last example, and it is a subset operator, and we are defining subset operator on power of s. So s is a set, and power of s will contain all the subset of s. Okay, so we are defining this subset operator on power of s. Now if we have s like 1 2 3 4, and we have power of s like containing 1 2 3, or 1 4, like this, and 2 3, something like this, consisting of all the subset, and we are defining something subset operator on power of s, and we say that 1 is a subset of this power of set. So we are defining a relation which will contain all the subset on the power subset of s. Okay, so is it reflexive? Definitely it will be reflexive, because it will contain all the entries of the power set, right? It will also be anti-symmetric, because if it will contain two entries uh, in reverse order as well, so they must be equal. And it is also transitive, because I'll show why it is all, just a second. So for reflexivity, we will see that if a is a power subset of A, correct? So it is reflexive. If we say that A is there and it is a power subset of its power subset of B, and B is also a subset of A, then definitely A has to be equal to B. So it is antisymmetric as well. Okay, and if we say transitivity, so A is a subset of B and B is a subset of C, then A is also a subset of C. So it is transitive as well. So hence, power subset is also a POR, partially ordered relation. Okay, now comes the question of what is a poset. Okay, so we will see about poset next. So right now we just have learnt about partially ordered relation. In next video we will be learning about what is poset, right? So that's all for this part, and keep watching. And if you do have any comments or question, please comment in the comment section. Thank you.